looking inside for their needs in life. They wanna be liked by everybody in sight, but trust me, being free ain't spotlights. No, it's long nights and it's long fights with yourself all the time to get your mind right. But if you put in the work, you can find the light. Alright, I'll do anything that I feel like I wanna do. I'm living life like I got nothing left to prove. No end in sight, just always staying on the move. I'll go all night if that's just what I gotta do. Life's too short to care about what you can't afford. Memories are in what you explore, so just don't be ignored. Go ask for more, go ask for more. 'Cause I've been living life right like I could just die any minute. Going for a ride down the side, PCH, country limit. I don't need a guide, follow lights, take me where I wanna visit. Are you alive? Or just breathing? 'Cause I've been living life right like I could just die any minute. Going for a ride down the side, PCH, country limit. I don't need a guide, follow lights, take me where I wanna visit. Are you alive? Or just breathing? 'Cause I've been living life right like I could just die any minute. Going for a ride down the side, PCH, country limit. I don't need a guide, follow lights, take me where I wanna visit. Are you alive? Or just breathing? 'Cause I've been living life right like I could just die any minute. Going for a ride down the side, PCH, country limit. I don't need a guide, follow lights, take me where I wanna visit. Are you alive? Or just breathing? Flashing red lights, driving at night, windowless ride, feeling alive. Nothing in sight, forever in flight. Follow those lines, we'll make it this time. Blurry street lights, work as a guide to memories that we're making tonight. Oh yeah, we'll make it tonight. Yeah. I'll do anything that I feel like I wanna do. I'm living life like I got nothing left to prove. No end in sight, just always staying on the move. I'll go all night if that's just what I gotta do. Life's too short to care about what you can't afford. Memories are in what you explore, so just don't be ignored. Go ask for more, go ask for more. 'Cause I've been living life right like I could just die any minute. Going for a ride down the side, PCH, country limit. I don't need a guide, follow lights, take me where I wanna visit. Are you alive? Or just breathing? 'Cause I've been living life right like I could just die any minute. Going for a ride down the side, PCH, country limit. I don't need a guide, follow lights, take me where I wanna visit. Are you alive? Or just breathing? I'm in a race that everybody's chasing fast. They wanna be that someone on the screen at last. They ain't looking inside for their needs in life. They wanna be liked by everybody in sight, but trust me, being free ain't spotlights. No, it's long nights and it's long fights with yourself all the time to get your mind right. But if you put in the work, you can find the light. Alright, I'll do anything that I feel like I wanna do. I'm living life like I got nothing left to prove. No end in sight, just always staying on the move. I'll go all night if that's just what I gotta do. Life's too short to care about what you can't afford. Memories are in what you explore, so just don't be ignored. Go ask for more, go ask for more. this ride, feeling alive. Nothing in sight, forever in flight. Follow those lines, we'll make it this time. Blurry street lights, work as a guide to memories that we're making tonight. Oh yeah, we'll make it tonight. Yeah. I'll do anything that I feel like I wanna do. I'm living life like I got nothing left to prove. No end in sight, just always staying on the move. I'll go all night if that's just what I gotta do. Life's too short to care about what you can't afford. Memories are in what you explore, so just don't be ignored. Go ask for more, go ask for more. Cause I've been living life right like I could just die any minute. Going for a ride down the side, PCH country limit. I don't need a guide, follow lights, take me where I wanna visit. Are you alive? Or just breathing? Cause I've been living life right like I could just die any minute. Going for a ride down the side, PCH country limit. I don't need a guide, follow lights, take me where I wanna visit. Are you alive? Or just breathing? I'm in a race that everybody's chasing fast. They wanna be that someone on the screen at last. They ain't looking inside for their needs in life. They wanna be liked by everybody in sight. But trust me, being free ain't spotlights. No, it's long nights and it's long fights with yourself all the time to get your mind right. But if you put in the work, you can find the light, alright? I'll do anything that I feel like I wanna do. I'm living life like I got nothing left to prove. No end in sight, just always staying on the move. I'll go all night if that's just what I gotta do. Life's too short to care about what you can't afford. Memories are in what you explore, so just don't be ignored. Go ask for more, go ask for more. Cause I've been living life right like I could just die any minute. Going for a ride down the side, PCH country limit. I don't need a guide, follow lights, take me where I wanna visit. Are you alive? Or just breathing? Cause I've been living life right like I could just die any minute. Going for a ride down the side,
Time to turn off the
PCH
music.
country limit.
All right, let's get this going. Hey, everyone. Mic pulled in. We got 7 viewers today. Fantastic. Thank you, everyone, for showing up. We got chat open, so please jump in chat, say hi, let me know who you are. And we're going to start bringing up our presentations. So, how many of the people who are watching tonight were in the first live stream? So I know how much I got to recap on because we want to power through the last of this. We have quite a bit of information to go through. We're going to go through a lot of the. We already went through the power flow of the transmission. We went over basic services that you can do, and now we're going to actually be getting into the software. What is the TCM telling the valve body to do? How is the valve body moving everything around? Sorry, I got a puppy on my feet. Hey, puppy. No, no play. We played. Sorry, the puppy hears me talking and he doesn't know who I'm talking to. It's just me in the house today. All right, so let's find out where we left off at. Who we got here? Midwest Encyclopedic. Hi, Joe. Just some guy who spent yesterday arguing with a pinch bowl. Oh, I'm sorry, man, but dude, I hope you won that argument. Saw the entirety of part 1. Fantastic. Hope there was some good information in there with you. And if you got any questions, let's get through that review. Bring it up during review. Canadian Diesel. Hey, how you doing? More what? No, laughing out loud. Hey, buddy. Hey to you too, sir. Glad to see we have some returning viewers. That's always cheerful. The C? Let's see. We made it how far? We made it very, very far during the first night. And if I remember correctly, we stopped in about this area right here where we started talking about, well, this is where I wanted to stop so that we could start talking about the valve body operation and the commands. All right. If we have no other questions, then we will just quickly hit our recap. I'll cherry pick some information here. Uh, yeah. First thing is, make sure you're using some sort of a tool to hold the torque converter in position when you remove and replace. Make sure your torque converter is seated correctly when you're going to install it, because if that torque converter key doesn't line up correctly, you're going to cause problems with your oil pump. It's going to smash and it's going to cause some very, very big damage, or it's going to push the linkage of the main shaft into the case, and you're going to get some more problems. Right here, is my mouse cursor showing up on the screen? Nah, it's not. So I got a 4 millimeter gauge right there. Oh, I see. Sorry. I got too many monitors up, folks. So sorry. Yeah, now you can see the mouse cursor. Cool. So, real important note right here. No, do not go backwards. I selected a pencil, good sir. Why is that not showing me a pencil? There it is. Pen. Right here, that's a 4 millimeter brake gauge that I'm using to show how I make sure that that torque converter is seated correctly. Now, that is going to be different per manufacturer, so you're going to find that specific information in your service data. So make sure you're following service data. But when we're talking about Subarus, that 4 millimeter or less, that is a good rule of thumb to use. I have that dialed into one of my pocket screwdrivers. I just grinded it down so I can use that for pocket reference. That just goes to show how many I replace. Special tools I use for removing oil pans. I really do like this tool right here, the JTC. It's in my Amazon store, so you can look it up at any time you want. Runs at about 45 bucks. There's some knockoff versions of it, but I've used the knockoffs and they disintegrate really fast. I probably have about 1,000 engine oil pans and transmission oil pans with this baby, and it works really good on those Jeeps too, especially the older ones with the straight six. It's real nice. Once you hammer it in place, then you can use this little chamfer right here. You smash this part into where the gasket maker's at, between the block and the pan. And then this long piece rides along the pan, and you're hitting this chamfer right here, and it's keeping the blade in and it's pushing it down the line. And that is a double beveled blade, so it's not going to cause any harm to these aluminum blocks. This picture right here, we're representing the TR580 Generation 1. It's divided up into 4 segments. The TR80 Generation 2, we lost the yellow section. It just became all one piece back here. So it became a 3-piece assembly. When we start talking about the big CVT, the where's my big CVT at? She's in here. She's in here. Okay, the 690. The 690 is just a beefed up TR580 Gen 1. It's got 4 pieces of the case. The power flow is the same, and we've just really upgraded the bearings. We've upgraded the planetary gear set, the chain, the drums, everything's just beefed up. It's really what the Generation 1 TR580 should have been, and If we could just get rid of the 580 and run the 690 all day, I don't think we would have as many problems as we do. For those of you who are curious as to why we have numbers for our transmissions, the 580, the remarks, the 580 and the 690, it's just describing the distance between the center points of your two variators, which would be your CVT pulleys. That's all it is. Not gonna. I'm a stickler about special tools, so look at your service manual for your special tools. On these Generation 1 vehicles, the 2010 to 2014, and think the 15s through the 19s, we went with a funky uh, subframe design where we got rid of the under engine mounts. There is no cradle for the under engine mounts. Okay. The under engine mounts, they are supported here on the sides of your transmission. So when you remove a transmission, you got nothing holding your engine up except AC lines and coolant hoses, and your engine's going to fall through. So what do you have to do to compete that? Well, you got to get one of these multi-point engine stay tools here, and I have a couple of examples that are my favorites to use. You got the Norcos 78099. It's a 4.1. This one's actually really good for vehicles that have a lot of this plastic shielding, and you can't just get a good generic spot. So you could really customize this thing out for a bunch of different vehicles. It does run at a higher price range. I've seen it as low as $700. Be aware of some knockoffs out there. So if you're buying it from Amazon, you're buying it from eBay, could be a knockoff. And the knockoff isn't made out of iron, it's actually made out of aluminum. And then these J hooks and these posts that come down, the threads on them are really crappy. These knobs are super crappy. So basically, as soon as you put it up in the storage and gets kicked around a couple of times, it's just going to be trash. It's going to be bent, and all your nuts and bolts and your hardware are going to be crap. So buy from a known good vendor. It's going to cost you a few $100. The cheaper solution is by OTC. They're just using some really, really thick pipe here, and you have an adjustable mount here that slides on this shaft. You put it on the strut tower. Then here's the other one, and you put this T-post right here on the front brace, not the radiator core support. You got to put it on the front brace. If you don't have any area, as like you can see on this vehicle right here, this would be kind of a difficult setup to use. So you'll have to improvise by making something, or you'll just have to shell out the money for this nice one. But if you're just doing Subaru, so far this T-post, this cross has worked out very good. Some people have modified this with their own jigs. So if you're a fabricator, more power to you. I'm not too much of a fabricator when it comes to welding. About the only welding I can do, unfortunately, is JB welding. I do have a splatter box from the Horrible Freight, and that's really only good for welding nuts to broken off bolts. I have not done anything to improve my welding skills at all. Time is something I don't really have. During the last review, we hit up on these chains, how we're getting our different gear sets by one pulley opening up more than the other and creating this quote unquote infinite gear that they advertise. And these gears, the way that they control the size of them is with line pressure through the primary pulley. Okay. So when the primary gets bloated with line pressure, we're just pushing in oil into it. It's going to squeeze this chain, it's going to pop it out. And then down here, there's no oil, there's no line pressure, there's just a return spring. And this chain actually pulls up between the pulley and it spreads it apart. And that's how we're creating our low gears and our high gears. There's a picture of our upgraded planetary gear set on our TR690. It's a double planetary gear setup. It's just stronger. And we are now back where we left off. Wow. A lot of chat there. Let's catch up. We got some new folks here. Garage Monkey, what's going on? Always a pleasure to see you in the chat. I see Company 23 has a tool to hold the torque converter now. Ah, yeah, I think that's a flywheel tool. That's a flywheel tool. For torquing down the bolts on your flywheel. I was looking at that during my research, so I'm gonna validate that. Company 23 stay tool. Yeah, they're calling it a flywheel locker. So let me drop the comment. Present. Yeah, so is this the one you're talking about right here? This $29 locking tool? Because that's what I came across. I'm surprised that they haven't tried to make a torque converter stay tool. They have a cam stay tool, and that was it. By the way, if you're doing STIs, their cam stay tool is amazing. It's very easy to adjust, install. Don't get the knockoff stuff. It's disrespectful to them. They kind of came up with that idea. So help those people out and don't give money to those wish.com knockoff vendors. Grouch Monkey says, laughing out loud. Turner, I was white girl wasted last night. Oh, White Claw, huh? Mr. Fluffy, thank you for showing up today. Holy smokes, I didn't know rear wheel drive cars had CVTs as well. Very interesting. Yes, you can CVT anything. Uh, Basically, our CVT transmission, uh, we just merged the transfer case into the tail housing. So instead of having a transfer case bolted to the output shaft, the propeller shaft, the drive shaft, whatever your vocabulary is, and then throwing another front shaft to the front axle. We just made it all one thing. Yes, I think some of these transmissions are too small for their applications. Very much agreed. A lot of it really just comes down to the marketing team trying to keep the vehicle in a price range where it needs to be. But the way that I think about it is, if you don't make a lot of different things to bog down your factories, and we just made a lot of the one thing, then you can reduce the cost of that one thing. I've been harping on my manufacturer whenever they ask for input, and I tell them, let's stop making four different trims of radios. Let's just make one badass radio and then share it with everybody. It would be so much easier, especially with software updates and with troubleshooting, because we're only troubleshooting one platform. But when customers come in with concerns about these touchscreen radios now, these big tablet things, these Tesla screens, we got four different variations on current model vehicles to go through. And hey, yes, hello, Mr. Fluffy. And we got GM in here. Rick Winch, thank you for showing up. I do have my PP draw on order. I called the Matco guy, and he says he's got my name written on it. Hello to you, Dave, too. Sex your rights. It's for flywheels. Yes, it just by looking at it, man, I was like, "Oh," and then I went, "Nope, damn it." But, a lot of people have kinda made their own just with a piece of bent metal, just go to the homeless despot, the Home Depot, and you can probably find a hurricane tie that you can bang into place and manipulate. It'll do the same thing. All you wanna do is just make sure you have a little tension on that torque converter so when you pull out the transmission, it just doesn't stick in there. I mean, even the special tool doesn't do a lot to hold it. It's only holding it on by just like a couple millimeters. Garage Monkey says, for Subarus, I don't use a flywheel tool, kind of just made my own. Yep, make your own. I forgot to this week. I really did want to take one of the Subaru ones, and I was going to hammer it out with a 5-pound sledge. It's going to lay it flat and take measurements. So if anybody wanted to cut their own out of sheet metal and then bend it in a vise and actually have a shapen one, I wanted to make that available. All right, let's get our circus show going on here. Woo-wee. I got a lot of notes here, and I didn't do my homework. Ah, don't do that. Sorry, I need one more monitor to know what's going on. Midwest Atlantic, welcome to the show. We're just about to get started. Ours only has front wheel drive, and we achieve all wheel drive by bolting a differential to the converter side of the trans, and pass side axle passes through it. Oh, it's like a power transfer unit. I think that's kind of how Ford is manipulating theirs. They're just using a really, really tiny multi clutch power transfer unit that they said was non-serviceable until they started blowing up 30, 40,000 miles down the road. Now they have a second generation that has a drain and a fill plug in it. And if you have a Gen 1, they sell a kit to drill your own drain plug and fill plug. Or maybe they had a drain plug and they never had a fill plug. Can't remember. I have to look up that Bolton. But that got a pretty feisty. And if you do have a Ford with a power transfer unit and it did fail and you are a first owner, you can call the Ford hotline, like the 1-800 Ford America, and you can ask for assistance in repair because a new unit and labor to install it is quite pricey. Very, very pricey. I did a couple of those and it was not a fun job. But once you get a couple of them down, they're really easy to do. All right, so let's look at our slides here. What's going on? I got my pen handy. All right, so this is just a basic block diagram. I'm pointing arrows at our front tire, pointing arrows at our rear tires. That block right there, that's our engine input that comes to our torque converter. And then following our basic power flow from the TR580, this is a TR580 and a TR690 power flow. We're going right into the first primary reduction gear so that way we can change the power flow laterally, okay, the horizontally. It's just through the shape of the transmission. We just have to transition it down. That's all we're doing right there with that gear set. Then we go into our pulleys and our chain. Then we hit our secondary reduction gear set, which then engages our forward and reverse changeover mechanism. Everything right here in the black box that is solid black right here. That's my horrible square. That is our control valve body. And these are our solenoids that are doing the magic and wearing out. Get the pen off. I don't want the pen anymore. Make the pen go away. Dang it. Make my pen go away. Pointer options, pen. Oh, there it is. Sweets. Sorry. StreamYard and slideshows do not go together very, very well. Okay, so our engine speed is measured in our RPMs, our RPMs, as I will call it. Okay, it's a mechanical connection to our torque converter, and that mechanical connection continues through our primary reduction gear, as I summarized before. All right, the primary reduction gear is monitored by the primary speed sensor. So I want you to remember this. if you're reading the PID data, okay, on your scan tool, your primary speed, that should be very, very close to your engine speed. That is a good way to tell that you have good linkage between there. If you have any delay, make a note to that when you're doing your diagnostics. Okay, our torque converter has a 4 hydraulic circuit control to lockup status. All right, so we have some very interesting key things that control our torque converter lockup. Okay, we have a lockup duty solenoid, we have a lockup control valve, we have a switch valve, and a lockup on off switch. Okay, all that is indicated right here with this dashed line going down into this circuit right here. We'll talk about separate like that. Our pulley chain has 4 hydraulic circuits. Okay, we're talking about the pulley and the chain right here. We're going to follow that dashed line down and we're going to get into a group of solenoids and how they talk together. Then we have another group of solenoids for our changeover mechanism. That's what all these dotted dashes are. That's what I'm getting to imply. Our all-wheel drive mechanism has its own all-wheel drive control solenoid. Subarus, they are an all-time all-wheel drive, but we are front-wheel drive biased, people. Um, the STI, that's a different type of all-wheel drive. Don't even worry about that. If you're here for STI all-wheel drive questions, this information will not apply. I will have a separate course on how that works because the STI has ways of flip-flopping 40% of its power front to rear. Uh, Now, a lot of these solenoids and a lot of these circuits, we can use a bidirectional scan tool and we can command these solenoids on and off as we please to see if it gives us the indicated change that we're looking for. So you could use a bidirectional scan tool and you could command this all-wheel drive solenoid off and it would not allow power to go to the rear. So if you're trying to hunt down a transmission noise, the first thing that I always do is I command that all-wheel drive circuit off and I drive the car and I see if the noise diminishes or if it sticks around. If it diminishes or goes away completely, then I know there's something in the tail housing that's a problem, and the front end of the vehicle is good. Now, the front end of the vehicle, is it hooked up hydraulically like this all-wheel drive? Okay, because remember, this is a multi-plate clutch pack here, as we described in our session 1. It locks up through the solenoid applying hydraulic pressure. So if you shut down that circuit, you don't get rear wheel drive. The front wheel drive is hard linked together. Okay, it's got a gear, it's got a shaft, it's got a pinion, and a ring gear. That's hard linked together. It's always going to stay engaged. So if you don't have front wheel drive, you have something mechanically broken. Why get rid of erase pen? Yay! All right, let's move along. No. Aha. There we go. Okay, moving into our first circuit of choice, we're going to talk about our variators. That is our CVT pulleys. The dotted lines here indicate our designated solenoids that we're going to be talking about. So we're only going to be worrying about the items in the red box. The blue boxes are indicating the components that we're talking about. And what's really nice about this block diagram is everything is in order of operation. Okay, our primary down talks to our primary up, and then it goes through a flow rate valve. And our secondary pressure linear solenoid has a straight shot to our pulleys. Okay, the primary up duty position. All right, so guys, these things are uh, pulse width modulated in order to sustain the position that they want, in order to create this infinite gear ratio. Because if we just flip this pressure on like a light switch and we held it there, it's just going to go full beans and you're going to make one gear. So we have to throttle it on and off with this pulse width modulation. Is everybody familiar with what pulse width modulation is? PWN. Because if you're not, basically just think about holding that light switch and flipping it really, 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 really fast, and that if you can switch it so fast that the light stays at a constant on, that's pretty much like holding it on. And then you flip it kind of slow, you get it kind of in the middle, the light's a little bit dim, and then when we have like kind of like a low pulse on, that would be a low. So we're just changing the frequency of the pulse width in order to change that pressure. That is how we control the pressure with these digital circuits. We do not have anything like a valve opening up, like if that was a hole, and then just kind of being like, here's a little bit of pressure, there's no pressure. Here's a lot of pressure. We don't know. That's not what's happening. Not at all. Okay, our primary up duty position, the primary flow rate control valve. Okay, we apply pressure, the primary down duty position of the primary low rate. Yep, yep. All right. So when we get our combination of our two our two pulleys working in sync, as the two our gear ratio is created from applying the pressure to our pulleys. That's what I'm trying to translate there. So if you're monitoring the gear ratio PID, you should your gear ratio should change with how your pulleys are engaging. If your gear ratio is erratic, then that means that you need to focus your diagnostics on your line pressure to your drums, and these you need to start diagnosing first the solenoids and go from there. And checking my notes here, which are scattered. So sorry, guys. I should have. I got some typos in here, and it threw my brain off. Okay. Normal primary up duty ratio will initially go very high when controlling up ratio and then increase slightly. All right. So during a normal drive sequence, if you're monitoring your primary up duty solenoid here, when you do your you do your initial takeoff, you're going to get a surge of pressure. And that is the TCM trying to give you that low gear for takeoff. And then it's going to dial down. Now, make sure you're watching the timeline at the bottom of your graph as you're monitoring that PID data so you can determine how long it's holding on to that low gear. If it's holding on to it too long, you more than likely just need to get a software update. But if it's letting go of it too soon, then you want to check your fluid levels in your transmission. And then, of course, start troubleshooting your line circuits. Now, our primary down solenoid right here, this is what's responsible for draining the circuit of pressure. So we have our primary up, which fills up the primary solenoid. I'm sorry, our primary up fills the first variator, the primary pulley. Sorry, too much lingo today right now. Our primary pulley is filled with liquid from our primary up solenoid, and then it is commanded to drain by the primary down. As I said in the recap, the only thing that's going into the secondary is lubrication, and it has a mechanical assist for closing with a heavy duty spring. So all the line pressure is done through the primary pulley. So here is what it looks like when you graph out your PID data. If your scan tool has this ability, all right. And when you're graphing this information out, make sure that you have already done some practice with graphing out information before. Some scan tools that do offer graphing, they're not the best at graphing because they just don't have the ability to update really fast. A good example that I brought the show off is this AutoFix D1, the D1 and the D1 Lite, they have the same tablet processor in them, and the signals are very, very choppy. It's really hard to see the detail and the updates that is happening with this processor. So when you're seeing the primary duty cycle of the up solenoid kick on, I just see a spike. I don't get a nice square. Unlike this new launch one that I'm playing with right now, that I just made a couple shorts about, this guy is fantastic at updating. It's very clean. Now, to also harp on, losing my voice already, that's not good. I Depending on the power of your scan tool, do not graph more than 4 things at once if you can help it, so that way you maintain the best resolution. That's just a rule of thumb when it comes to monitoring PID data, and especially graphing PID data. Now, obviously, if you are rolling with more expensive scan tools, like I have the Snap-on Zeus, this guy has no problem data logging about 10 to 20 PIDs at once. And if you have the dealer laptop, that thing can graph everything with no dropouts. So if you're doing a lot of Subarus and you're doing a lot of Subaru transmission work, I would highly encourage you to just invest in a subscription to the dealer laptop, because that thing data logs the best. You don't have to worry about picking which ones you want to do. You just drag and drop them all and you go for a test drive. It doesn't get angry. And I have data logs that are like 20 minutes long, and it has no problem processing all that stuff in memory. We got a question from Jeff. Hey, Baha. How you doing, man? May not be on topic. Got a TR690 on an Ascent that reverse works as normal, but drive feels like it's in neutral. Is there I can't read. Is there a variable other than the valve body that I could look at? Yes, you're actually in the right section where we're going to be talking about that. You might have something going on with your forward reverse clutch setup mechanically in the transmission, or you could have a valve body problem in the transmission. But I ask you, is how many miles do you have on your Ascent? Because you might want to think about going to a dealership for help so you don't lose money buying parts. Always consider your dealership first for help on a lot of these advanced technology components, as they have a lot of extended warranties now out there, and the mom and pop shops, they will not tell you about these extended warranties. Not because they don't want to, but more because they just don't know about them. So drop on in, let them know what's going on, and see if you are eligible for a free diagnostics, and they can look at it. You might be eligible for some free repairs. And then keep your ears to the grindstone, because there was just a law firm that finally picked up a class action lawsuit against the Ascent transmission for chain slip. All right, so where are we at in the notes here? Oh yeah, so we're talking about what's going on. So I numbered these items right here. So our one corresponds with our 1 point right down there, so you kind of know what the call outs are. So on call out 1, we're going at 17 miles an hour, and keep an eye on that. I think I have sliver ones in kilometers, because my scan tool keeps bouncing back to metric. But we do our original takeoff. You can see segment number 1, we're at 40% duty right here. But what is our primary down doing? It's shut off. That's what we want it to do. But then you see when our primary down duty kicks on right here, our primary up shuts off. That is basically what you just need to take away from this. When you're looking at your PID data, and you're looking up your primary ups and your primary down, and you want to see if everything's okay, you really want to see opposites. When the up is on, the down is off. And when the down is on, the up is off. That's it. Because remember, it's just shutting off pressure to the primary pulley to just maintain its uh, infinite gear ratio. And it just does that at an impeccable rate. And that's all you're looking for is on, off. And you want to see the reciprocal here on the other side. Now, if you see any erratic, harsh spikes, and by that, let me get rid of these marks so you know what I'm talking about. Pencil, screen, pointer options. Yes. Erase pen. Boom. Gone. Okay. So I'll do it over here in the white. But if your primary is coming up and then all of a sudden you got like this hiccup, like right there, that bad. That's bad. But you see how we have a little bit of chop right here? Don't worry about that. That's good chop. That's okay. It's only when you have just crazy like spikes. All that stuff's bad. So when these things are moving around, they're creating your gear ratio. And here's our gear ratio increasing right here. As our gear ratio is, as our, sorry, I'm mumbling. I'm so sorry. Let me speak up and get what we're talking about. Let's go to our gear ratio and talk about this. The gear ratio right here, you'll notice that it started low because we were in a coasting mode. Our miles per hour, even though we're only going 17, we're kind of coasting. The vehicle wants to conserve energy. It wants to conserve fuel. We're probably in a fuel cut mode right now. So we're coasting and it's keeping this overdrive gear open as long as it can. But eventually, when the speed drops to a certain point, and that certain point is not identified, but you could probably go with maybe single digits on your miles per hour, it's going to start kicking in down here. Look at our gear ratio. It's going to start kicking in a low gear because the transmission wants to start staging for a takeoff. That's what you want to be looking for when you're test driving the vehicle. You want to look and you want to make sure your primary up and your primary down, they're the reciprocal of each other. And then as you're coasting from about 20 miles an hour, coming down to a stop. So you're going to need some stretch of road where people are not going to tailgate you and hit your butt. You want to see that overdrive gear hold on and then eventually shut down and go into a low gear as you come to a crawling stop. And crawling stop is single digits miles per hour. How you doing, sir? Fellow Subaru mechanic. Hey, it's good to see you here. If you got any input, please go ahead and throw it in. This is my first time presenting materials, so I got a lot of stuff to get out of my head and put onto paper. All right, so how are we creating our low gear? Well, basically, when we're going into our low gear range, our primary pulley has swelled up all the way. It is a big gear, and it has pulled the chain and separated our secondary pulley, and now it is riding on the shaft, and we have a tiny gear. So that big gear has to turn around a lot more to turn that little gear. That's it. We want overdrive, it's the other way around. I might have gotten ahead of myself on the slide here. Yes, we talked about everything. Yep, we covered all that. So, guys, everything I just said, that's computer driven. That's the computer doing all the work right there. If you're ever dealing with a customer who has a drivability issue and you don't have any kind of check engine light, you don't have any codes to chase, the tune up on the car is good, the fluid levels are good, look for a software update. There's a lot of software updates out there, especially up there in the north. The north experiences a lot of drivability issues at cold weather startup, because you guys get a wicked version of cold weather startup. During cold weather startup, the pulleys are designed to slip, and you're going to get a power loss, and they're slipping to create friction to warm up the fluid faster, because it wants to get that fluid at optimal temperature within about 60 seconds. If it doesn't achieve that, then you're going to get drivability issues. So if you're trying to replicate a cold start concern, you might have to ask the person to leave the car at your shop so you can start it first thing in the morning, because obviously when they brought it to you, everything's warmed up. You're not going to be able to uh, replicate that cold weather startup concern, because maybe I would say leaving it in a parking lot for 2 or 3 hours may not be enough to cool this sucker down. These transmissions, they take hours to cool down. They are heat soaks. They're heat soaks intentionally because it wants that fluid to stay warm. Here's what I'm talking about with our duty control. So we are scoping the actual solenoids right now. And you can see right here where the primary solenoid is being commanded by the confuser. That's our computer, our TCM. And it has these sequences of really, really fast intervals. Look at our timeline down here. 100 milliseconds per division. Okay. This isn't a scope class, but I just want to point out, because we have a lot of scope capture on here, you're going to have two types of screen scope setups that you might come across when you're looking at drawings. You're going to have some where they're going to tell you the time base for everything from left to right. And then you're going to have other ones that are going to tell you the time base on a per division. So make sure you read it correctly. So when we're looking at this is 1 division, 2 division, 3 division, and so on. So if we were to count this all up, we are looking at almost an entire second here. 1,000 milliseconds equals 1 whole second. Imagine that. So you could definitely see how fast these things are switching on and off. A tenth of a second, 100 milliseconds, that's a tenth of a second. And this one segment right here, this primary down solenoid was commanded 1, 2, 3, 4, 5 times. Super fast. How many times was this up one commanded? 1, 2, 3, 4 times. So it can really trim these things very nicely. Now, what are these angry spikes coming down here? Hey, that's just the magnetic field of that coil shutting off. When we run electricity through a wire, I get my demonstration wire, which is my USB charging cable right here. I need a longer one because they're all plugged. Aha. All right. Single piece of wire. My finger is an iron rod. Wrap the wire around it. Okay. Now I make all those pixies really angry. I shoot 12 volts through it. That is going to create a magnetic field. Think of a magnetic field like a boat going through water. You get that riptide effect. Okay. And the faster you drive your boat through the water, you make bigger waves. And the engineers kind of figured out that if you drive a boat through the water and then you bring a second boat through its riptide, you can make even bigger waves. So you can make compounding power that way by taking that invisible magnetic field. That's another segment that's not going to get talked about here, but that is a really fun thing to go on a YouTube search about, is learn about magnetism and magnetic fields. We use it a lot in our vehicles. That's why whenever there's an electrical problem in a vehicle and you're kind of having a hard time trying to figure it out, that's where oscilloscopes come in really handy, because they allow us to see these magnetic fields collapsing. That's what these down spikes are. That's that magnetic field collapsing. Sometimes they can collapse really hard and they can make a big spike, and that can make another magnetic field that's close by. It can make it angry because it can get picked up by another circuit. A lot of times these magnetic fields, they get disturbed by aftermarket wiring, aftermarket components. because they're creating their own magnetic fields and they piss things off. But that's it. Um, these pictures here on the right, this is actually from service data. So service data is really, really nice about giving you these graphics. You can find that uh, these graphics are available through the All Data and who else is out there? Mitchell, Shopkey, and there's another one I can't think of right now. But Subaru hides these under a tab called Diagnostics. And you'll go to the input output chart and it'll have all these waveforms corresponding to the pin call out on the TCM. It's very nice. You just got to play around and find it. If at any time you have your primary up and your primary down on at the same time, you got a problem. They're not supposed to be on at the same time. One circuit is supposed to be shut down while the other circuit's being driven. Okay, what does the secondary pressure linear solenoid do? All right, and the secondary solenoid operates at a frequency of 2 kilohertz. The fast operating speed ensures at a constant correct clamp. I think we already went over this. Primary up and primary down solenoids control the position of power flow. Yeah, blah, blah, blah. Secondary, secondary, secondary. All right, so secondary pressure, that's our primary up. And that's filling this void right here into this pulley set right here. All right, secondary solenoid operates at a frequency. Clamping force will lower gear ratios, increasing the ratio. That's the note I'm looking for right there. All right, so as pressure increases, your milliamp increases. Your scan tool data does have a PID right here for the amperage that's monitored by your TCM. So take this information with a grain of salt when you're looking at it. If you suspect you got a bad TCM, then of course this reading's going to be bad. But this is all processor driven, and as the pressure increases, our milliamp reduces. So we see the pressure going up right here, and we see our amperage dropping right here. So you want them to be a reciprocal. That is it in a nutshell. There's no math formula to follow and see what's going on. You just want to run those two PIDs next to each other, and you want to just make sure that they're separating. Just like the primary up and the primary duty solenoids, how I said one is off and the other one's on, same thing. Just visually look at it, and that's about as far as that test goes. Look for abnormalities. Now, obviously down here, if this screen that we're looking at, this is an oscilloscope screen, and this is just how fast we are commanding this circuit on, and you are just looking for irregularity. This should be a constant 2 kilohertz signal on or off. So when it's on, it has a frequency of 2 kilohertz, and that's it. Okay, now we're going to zoom in on our circuit here for the lockup on off. Oh, Ray's got something here. This is going to be super specific for the cross-track hybrid. Doesn't the gear ratio go super low for B mode driving? Anything we should do different for that? Yeah, I purposely kept the Crosstrek hybrid out of here just because the Crosstrek hybrid has that DC assist motor in there that helps with your takeoff, and then it has those different modes of operation for takeoff. So we will have to talk offline about that more so I can fill you in about those specifics. Sorry about that. But good question. Thank you for that. Maybe I can introduce that somehow, but still kind of tailoring all this wealth of information here. All right, so we're going to talk about our operation here. Okay, so our lockup on-off solenoid controls the switch valve. Where's our switch valve at? Right there. So contestant number one, the lockup on-off solenoid controls our switch valve. Okay, the lockup duty solenoid controls the lockup control valve. Boom. So now you know who's the parent in this situation. These guys are the kids, and they got two parents telling them what to do. Who tells the lockup on off solenoid to do their job? And who tells the lockup duty solenoid to do their job? Well, parents get told what to do by the frickin' government, and that government is the TCM. All right, so the lockup duty solenoid controls the lockup control valve that provides hydraulic pressure to the piston that locks the impeller on the torque converter. A lot of words there. So our control valve sends our hydraulic pressure to our torque converter. There is a big diaphragm plate in our torque converter that's going to engage that lockup on there. And then when we want that pressure to come through, that's when our lockup on off switch solenoid opens up this valve and it allows the pressure to go through. Hey, no problems. I'm here to answer questions for you. All right, so basically our lockup on-off duty solenoid, it's just a basic on-off status that we're looking at. And then of course a duty solenoid, it's going to have a duty controlled signal. Let's see what we got here with some PID data going on. So we got our front wheel speed increasing. We're at marker 1, 14 miles an hour. Marker 2 is 15. So between those 2 points, we had a light acceleration. During that acceleration, as we were starting out at point 1, we can see our lockup duty ratio. It's skyrocketed. It's on because our lockup on off solenoid commanded it on. It's very important when you're reviewing these 3 groups right here. This lockup on off solenoid, the third PID we're looking at right here, this needs to be in an on state before your lockup duty ratio starts to come on. This comes on first because this is the gatekeeper. Remember, the lockup on off solenoid controls our switch valve. So if one is getting ahead of the other, you might have a TCM problem with not a uh, valve body problem, because the valve body is just a slave to the TCM. It's doing what it's told to do. And you might be able to fix that with the software update. If not, then the TCM's toast. It happens a lot. Computers get their brain scrambled for one reason or another. Our And then our lockup duty ratio. This is just an example of scoping of what it looks like. It is just B plus voltage right there. My slides are getting screwed up. Sorry. Okay, lockup on-off solenoid controls the switch. Yep, we already talked about this. I think this is a duplicate slide, gentlemen. Sorry, I will make a note of that. Duplicate slide. And that was slide 74. Okay, we get to the last segment here, which is our forward reverse changeover mechanism. All right, the forward and reverse linear control solenoid provides the controlling pressure that moves the forward and reverse control valve. Now you can see our block diagram. We're just going to follow this path right here. That's why this is super pretty. the forward and reverse control valve regulates the pressure routed to the manual valve. So we got a controlling circuit and we got a regulator circuit. The manual valve delivers hydraulic pressure to the forward clutch and the forward gear range and the reverse clutch and the rear gear range. Ta-da! We have described a block diagram. During normal operation, the pressure will be higher during low gear ratio and during acceleration. Remember that. That's a key thing to know when you're looking at your pressure. Normal operation, high pressure in low gear and high pressure in acceleration. The pressure will be lower if the vehicle encounters a split friction surface front to rear to reduce. Okay, that's no. That's those are notes I don't want in there. All right, so here we are. We're looking at our graphed information. The forward reverse. So the pins that we have here up on the screen, we have our accelerator open angle percentage. We have our front wheel speed in miles per hour, and we have this forward reverse linear solenoid, and we can monitor it in milliamps. Oh, I got dog spotted. Oh, you got that? Sorry. Dogs got excited and sometimes they nip each other. One's very jealous. Okay. So let's follow our path here on the movement going along. We have our throttle is opened up here on point one. Then we let off of it. We don't have any more throttle, and then we're coming back on. So you can see our front wheel speed is dropping off as a response to not giving it any more acceleration. So what happens in respect is we hold on to that pressure until we hit a point to where it drops off, and then we kick into our low gear and our pressure comes back up, and then it eventually dies off because our speed got low. But then when we engage our accelerator pedal again, our pressure is going to climb again. X mode. Okay, we're gonna hit X mode really quick here. Um, X mode is a kind of like a way of like a hill descent assist and a hill climb assist. All right, guys, there's no mechanical moving parts that X mode engages. It's all software. It's all software in the TCM. And when you're having an X mode problem, it's important to know that there is no X mode computer to diagnose. You're just running a different algorithm in the TCM, and the modules that all come into play assist is pretty much the entire car. And when the TCM talks to other modules, it's talking on a CAN bus. And if your modules are checking good, then you need to start diagnosing your CAN bus to make sure that they're talking to your TCM correctly. So when you're in X mode, it will automatically turn off at 18 miles an hour, and it doesn't come back on. So if you are in X mode to get out of a certain spot and then you exceed that speed, you will have to manually re-engage it. All right. So when you kick in the X mode, you're going to get hill descent control. You're going to get stronger multi-plate transfer clutch operation. That is the center diff. Okay. Engine torque control. It's going to limit throttle to your engine, so that way you're not going to get very sharp maneuvers. Everything's going to be much more intelligently controlled. You're going to get faster limited slip differential functions. your torque converter is going to get retarded as far as the lockup duty. All right. Because we don't want the car spinning out of control. We want to stay in a very slow crawl maneuvered situation. And X mode works in forward and reverse. When you turn it on, you get this cute little symbol. It, depending on the make or model of your car, it might be on the center screen or it might be on the gauge cluster. So reference your owner's manual for that. Uh, Key points here is you're seeing right there. Hill control is not cruise control. It will not advance the throttle settings to increase speed. Hill descent control provides braking automatically to maintain the vehicle speed, which exists at the time the driver releases the gas pedal or the brake pedal. When hill descent control is in operation, and indicator lamp on the combination meter and the multi. Yeah, I already explained that. Okay, during standby, hill descent control lamp stays on steady. When you're in hill descent control mode, and the TCM is going to do assisted braking, it's actually going to turn on your rear lamps too. So that way people know that you're braking. A little forward thinking there is pretty nice. It really wants to keep the car at about 12 miles an hour, but if you manually throttle over 18, it's just going to shut down. If you've never played around with your X mode, I do encourage you find a safe area and get used to all the extra noises it's going to cause. Because when X mode is activating your brakes for you, you're going to hear this really, really annoying, like sound a lot. And that is actually the hydraulic control unit in your engine bay regulating line pressure to your calipers on the four corners of your vehicles to help keep your car straight as you're crawling up a hill or you are crawling down a hill. Now, this isn't in the slides, but the new versions of the Forester and the Outback and the Crosstrek that have recently been released, the I always call it the Mountain Edition. Shoot, our new uplifted versions of the Subaru. The mind escapes me. The Wilderness. Sorry, yes, our Wilderness edition. The X mode has been the speed limit has been lifted very, very high. Uh, I'm not sure it's unlimited. I didn't read too much into it, but I know that you can go about 30 miles an hour with X mode in a Wilderness edition. And they did that for overlanding. All right. Again, we're pointing out that X mode is not a single control unit. It is actually software that communicates across your CAN bus. So if you're having problems with a vehicle not wanting to maintain X mode in the parameters that it's in, so if a customer says, "Hey, I'm going 10 miles an hour and I keep getting kicked out of X mode," you are going to have to diagnose every specific system about that contributes to X mode. That's your engine, your engine computer, your TCM computer, your hydraulic control unit, and you want to look at specific PIDs like engine oil temps, engine coolant temps. If any temperature on the vehicle, the engine, the transmission, the engine oil, the transmission oil, the coolant, any of that stuff goes outside its safety values, it's not going to let you go into X mode. The car is going to go into a safety mode. So if the vehicle's overheating because of coolant, obviously look at your radiator, look at your fans, make sure that's working, make sure your coolant doesn't have an air pocket in it, and then diagnose your coolant tip sensor and make sure that you just don't have a uh, faulty coolant temp sensor. And the best way to check your coolant temp sensor circuit is to watch your PID data with your little scan tool here. So you got engine temperature monitoring. And if you disconnect the connector from the temperature sensor, it goes to a high static value. And when you short it, it goes to a low static value. That's how you can test the integrity of your wires to your ECM. And then you can diagnose your temperature sensor from there for just being a piece of crap because they eventually go out. How's our time? 9:30. All right. The onboard diagnostic system detects trouble codes, generates display codes. All right. So when your transmission is having some problems, you will get a check engine light and you may or may not get a flashing AT oil temp light. Now, when you check the engine computer, you're going to get a generic P0700 code. And that P0700 code just says, look at the transmission computer, dummy. So you look at the transmission computer. So if you just have one of those cheap little $10, $20 scanners that can only look at engine computers, you're not going to be able to go any further from there. You're going to have to scale up to a full mode tablet there so you can look at all the computers. And obviously, if you have other computers that are contributing to the problem, like your vehicle dynamic control computer, you're going to need a tablet that can look at that too. So I am right now recommending the launch here that I have, the CRP. Uh, it's running at about $500, and that is about the minimum tool that you need to look at everything and data log everything and program everything. More about that in a separate session about scan tools. And checking my notes for anything else. Yep, that's it. The AT light only flashes at one speed. It's just like an on-off 2 hertz signal. Right. Before checking for DTC, you must connect data link. Yep. And the following servers in order. All right. Okay. A lot of big notes there. And this needs to be in a printout almost. A lot of call outs here. Okay. So we have about 15 points of fail safes that every sensor will go into if it has a problem. The primary speed sensor. If a trouble occurs with the primary speed sensor, the CVT continues to control according to the engine speed value during a lockup scenario. I'm going to have to print all that out for you guys. No, I don't want to sound that out. Okay, those are fail safes of what your individual sensors are going to go into. If trouble occurs with these, almost need to be separate slides. If trouble occurs with secondary speed sensor, the CVT continues to control the front wheel speed value. Okay, so basically what it's saying is if our secondary speed sensor, which monitors our secondary pulley speed, if that value drops out, it's going to default back to the primary speed sensor. And if the primary speed sensor uh, flakes out, it's going to default to the secondary because even though there's a reduction gear change there, it still knows the values and it can use math and it can kind of figure itself out and limp you somewhere where it needs to go. If your front wheel speed sensor uh, on your transmission, not your vehicle, okay, if that thing poops out, it has a fail safe. It wants to look at the secondary speed. If your hydraulic pressure poops out, it's going to fail into a constant open position, which means that you're going to have extremely harsh engagement when you slide through drive, neutral, reverse, and park. So you're not going to get soft transitions during the shifter. So if you have really, really harsh engagement, um, you might have a bad hydraulic pressure sensor that's flaking out. And there should be trouble codes for these things, but they don't always set if it is not happening enough of the time, or if it's not a constant short or a constant open. Yeah, more from there. Okay, TCM. We got callouts on your TCM, and you can use your service data, go into the diagnostics, and you can look at the IO charts. But these are really, really important to just kind of have as keepsakes in your notes to know where your basic powers and grounds are at. Whenever you're trying to diagnose a bad module, if you're suspecting a bad computer in a car for any situation, the first thing you always want to do is you want to verify your powers and you want to verify your grounds. So we have all the ground callouts and we have all the power callouts. Note that this TCM has two plugs on it. As far as our powers go, you have different types of power, the way that they are delivered. We got backup power supply. We have ignition power. That means that power is only being supplied to the TCM when the ignition switch is in the on position. And then you have hard set main power. Here it is at a better look of what's going on. So looking at our wiring diagram, just to point out in case you've never known, when you look at Subaru wiring diagrams, we have this little term right here, FB. FB stands for cabin fuse box. MB stands for your main fuse box inside your engine bay. So when you're trying to find fuses off of a chart, that is your simple call out there. When trying to figure out why power may or may not be going to your TCM, bear in mind that you have a hidden relay, and that relay is not in a relay box that you might be familiar with. The relay, there's no relay box that this is in. It's actually just tucked up underneath the dash. So here on the right-hand side, this is kind of a see-through diagram, hand drawing of the dash. And kind of about here would be the steering wheel. And right about here is the A pillar. So you're going to have to get your noodle in and push it up here by the pedals and look left. And more than likely, that thing is going to be pinned up against the wall, and there's going to be a bunch of other wiring over top of it. So be gentle when you're moving those harnesses around. You don't break any connectors, but there's a hidden relay in there. Because this relay rides on the A pillar, it's very susceptible to water intrusion from sunroof drains that are clogged. So if you're in a if you're trying to figure out why that relay went bad, pop open your sunroof if it does open. And whenever I open up sunroofs for diagnostics, I always ask the customer first. I'm like, "Do you open this up a lot?" And usually the answer is no. They just like to look at the sun through the glass. And I let them know that I have to open this for diagnostics. And if it doesn't want to close correctly because it's never been opened in a long time and it goes sideways, there's no manual close. You are stuck buying uh, new rails for your sunroof assembly. And that's more prevalent up north where you guys got a little bit more rot. We don't see that too much down here in the south, but that is something that can bite you in the ass. You just get excited, you're looking for something, you pop the sunroof open, and next thing you know, the sunroof doesn't close. So that's one of the no-nos of my diagnostics that I always preach, especially when you're doing multi-points. A lot of people like to depending on the shop that you're in, everything has a standard operating procedure like don't move the steering wheel, don't move the seat, don't roll down windows, because we're all afraid of that stuff not going back up and closing and going back into its original position. Where I'm at in my shop, we're a full service center. Being at a dealership, they want us to touch everything because if something breaks, they're gonna most likely goodwill it to the customer and just say that's just part of our inspection. We checked it, it failed. Sorry, we're gonna take care of you, but you'll probably be out of a car for a week. Okay, so what is this? we're going to get back to our power flow here. Our self-shut relay. Okay. If the TCM self-shut relay is not activated due to malfunction, even when the ignition switch is on, the transmission falls in a no control state because it cannot supply power to each solenoid. Even in this case, the TCM makes that oil temp light flash through a CAN bus communication code. Self-shut relay is located in the driver's side cabin area behind the BIU, smashed against the wall. Yeah, I forgot to mention that. The BIU is about right here, and it has a whole bunch of fuses in it. So you might have to unbolt that and push it out of the way. Let me erase my marks here. So let's talk about our power circuit again. So as you can see, the FB fuse, FB fuses, they're turned on by ignition power. So when your ignition key is in the on position, or if you have a push start and you press the push button twice, that's considered on position. We're going to see power come down here to this pin. Now, this MB fuses are in the engine bay and they're hot at all times. So we have one run coming right here to B1. It's always going to be hot. That's a good known. These other two right here, this is part of your self-shut relay, which are your self-shut relay, and that's what energizes your solenoids to come on. So we have constant power coming here to this pin on the relay, and it's ground activated through your TCM. So if this isn't coming on, make sure that your TCM is commanding this on when you turn the ignition key on. Once your relay connects, power then flows through, and we power up our solenoids, and then we power up the rest of our TCM. Okay, there is an all-wheel drive light on the gauge cluster, and where is it located? Right here, next to the oil temp light. Depending on your make and model and year, it might be in a different location. But when you initially turn your vehicle on, you know how all the lights on the dash turn on? That's called a bulb check mode. So you can find it that way by just powering on your vehicle. You don't necessarily have to start the engine. You can just turn the key to the on position. So that light actually can give you some call outs. And this chart is a little tricky to translate. So I'm going to do my best. I try to really try to kind of break this thing down and describe it over the air because there's paragraphs of information that try and teach you how to read this. All right. So the all wheel drive light, when the ignition switch is on, let me see if oh wait, all wheel drive light or blinks, blah, blah, blah. Okay, here we go. All-wheel drive light illuminates or blinks when the all-wheel drive is in specific control according to an all-wheel drive malfunction. Okay, so it's going to blink if there's a malfunction, but it turns on and then eventually turns off for normal bulb functionality, and it detects no fault. The all-wheel drive light always illuminates when the ignition switch is on, engine off. Light goes out after 2 seconds. And that's indicated by number 1 and number 1, normal operation. Okay. Operation number 2, right here. Light is on and it stays on the entire time. That means that you're stuck in front wheel drive mode. And number 3, it comes on for the 2 seconds and then immediately starts blinking. That means that you have a all-wheel drive malfunction. That's what you need to know. Oh, we're finally getting into our Gen 2. Hell yeah. Gen 2 is much more interesting design. We didn't lose any kind of hardware in the transmission. We just kind of shifted some things around. All right. We Tetrised it a little bit. Think about it like that. So we moved our forward reverse changeover mechanism. The pulleys, this is important to note on the generation 2, the pulleys, they actually stop spinning when you're in park or neutral. So if you're looking at your pulley speeds, they're only going to be turning and drive in reverse. We Okay, the weight load of the vehicle directly affects. Okay, yeah, yep. Ah, adding weight to the vehicle will affect our pulley operation. We have fail-safe operations, and we have moved our forward reverse changeover mechanism. With Generation 2 came about new fluids. So our high torque fluid, which is this orange color here, that's for our TR690. We got rid of this CVTF C30 stuff. That's gone. It used to be blue. Now we have CVTF2, CVT transmission fluid number 2. It's green. Now, blue did make a comeback on the 2020 Outbacks when we introduced stop start into that vehicle. So blue came back, but it's not under this call out anymore. This is a completely discontinued call out. So Subaru blue is back in the fluid. Part of the Gen 2 operation is we threw in these dampeners right here on the engine mounts, and those are there to help with vibrations at idle. So if you have the vehicle in gear and you're at a stoplight or a stop sign and you're experiencing some harsh vibrations and you're trying to diagnose something, take a look at these and make sure that they're bolted correctly or make sure that they're even there. Sometimes when these transmissions get serviced, those get removed and then people forget to put them back. They can just be damaged too, worn out, dry, rotten. Some other things that you should do for a vibration at idle, though, is one, you should check your fluid level, uh, do a transmission relearn. We covered that in session 1. You get a bidirectional scan tool. You go to the TCM, you go to special functions, you select relearn mode, and you follow the on-screen prompts of what it wants you to do. And it's basically going to ask you lift the vehicle off the ground, make sure that it's lifted evenly, not unevenly. So if you're going to try and do this with 4 jack stands, more power to you. I would rather do this on a 2-post lift and put it on the locks. That's very important. Put it on the locks because on a 2-post lift, they lift unevenly. So if the car's tilted a little bit, the vehicle is going to take that into consideration of a baseline and it'll learn incorrectly. It'll tell you that you got to have the temperature of the transmission fluid at a specific temperature of about 130 to 140 degrees. If you're outside that range, you're going to have to wait for it to cool down. If not, then you're going to have to wait for it to warm up. And then, of course, make sure you have no codes in any of the computers. So you got to do a memory clear. Now, I'll say this just as if you're going to do a transmission relearn, buy the book. It's going to tell you to first clear the transmission learning value. When you clear the transmission learning value, you also lose the rear differential learning value. So you will have to do a rear diff relearn before you can do a transmission relearn. And there's more troubleshooting if your rear diff does not want to do its damn job correctly. Keep in mind, our rear differential is an open differential. So if one wheel is hung up due to the spider gears malfunctioning, or maybe the fluid isn't warmed up in the rear diff enough to let those spider gears free spin, then both wheels are going to spin at different speeds. So that's what the rear diff learning mode is looking at when you engage it. It's going to send power only to the rear, and you want to see and make sure that the rear wheels are turning and they're turning evenly. There have been times when we have had to change the gear fluid in order to get good results. There have also been times when we had to do a parking brake relearn because we had too much brake pad drag. There have been times when we had to machine the rotors because the rotors had run out and they were catching on the pads. Those are all troubleshooting things you have to be aware of when you're doing a rear diff relearn. Anything that could hang up the rotational speed of that tire in any way, shape, or form, diagnose that. Because if your speed sensors aren't picking up the rotation, it's just going to kick you out of relearn and you're going to have to try again and again and again. And too many failures is going to make your ATF temperature run hot. And by the time it finally relearns, you got 200-degree ATF temperature. And now you got to go take a long lunch while that transmission cools down. On the Gen 2s, we moved this TCM to the top of the transmission so we can cook its brains. Yay. So it's no longer in the cabin by the driver footwell. It is uh, on top of the transmission. So if you are lifting the engine and the transmission assembly, trying to do work underneath the vehicle, be aware that you can crash this into the chassis and you can do damage. There is some heat shielding between that TCM and the transmission, but if you're getting a junkyard transmission, it may or may not be there, so you will have to come up with your own form of heat shielding. When the TR690, the high torque CVT, the TCM is actually right in front of the passenger strut tower. All right, some big changes that we did to it that were beneficial is we made it lightweight because we put more plastic in it. Okay, we did a lot of things to reduce vibrations from the Generation 1. We beefed up some oil passages to reduce the amount of load that was used to increase line pressure. So, more load on the engine means less fuel economy. So, by easing up on the passages and making them less resistant and getting to that peak pressure where we need it to be, it's putting less load on the engine. That's how we get fuel economy. And then everything here you can see in the picture. This is just some gee whiz engineering notes that we added to it. If I draw a line right here, that's our torque converter case. Then this is main case, and then we have tail housing. So as I said before, our Gen 2 is a 3-piece case. Another big change up that we did was the valve body is no longer in the oil pan anymore. The valve body is on top of the transmission. And we did that so that way. Oh, why did we do that? There was a reason why we did that. Oh, I remember. So it's because we were throwing this in Prezas, four-door sedans, and Legacies. We did it for the beneficial of the ride height of the vehicle, so it helped out with center of gravity. Now, because we threw the valve body up here into the top of the transmission, we had to move our reduction gear set here. So we lost that and we just chucked it over here in the rear. So we just kind of moved our power flow around a little bit. So our front reverse clutch is now in front of the primary pulley right here where it was in the back, and our forward reverse upgraded with a double planetary gear set. So we learned our lesson from the Gen 1 that the planetary gear set in it sucked. And the TR690 planetary gear set, which was a double gear, was awesome. So we left that planetary gear set in the Gen 2 TR580. Yay! The plugs for your differential fill got different. So we lost your tube here where we had a vent tube. That's gone. And now you got this 8mm hex, which gets stripped out all the time because people use really bad hex keys in there. You really want to make sure that they go in correctly and you got the correct ratchet and extension set up and you break it off nicely. The first time you try to crack one of these open, if it's never been cracked open before, you're going to think that thing is 50 foot-pounds tight. That's normal. What you just want to make sure is that your hex key isn't going sideways because it's cheap. Or maybe it's not seated all the way because that thing's boogered up with dirt. So clean that thing out with a pick and some brake cleaner. And I like to always just kind of give it a little tap, tap, tap with the head of my wrench and make sure that thing is keyed and seated correctly. Over here on the bottom of the differential side, this is your check spill plug. Very familiar to how we did differential fluid fills on the Generation 1. But instead of it being a 14mm bolt, now it's an 8mm hex. What else we got on here? A little bit of harness change. Right here, this is that fill plug for the differential I was talking about, how it had a vent hose right there. Let's hear it. The electrical harness for the CVT Gen 2 is secured to the top of the transmission under a sound insulation. Yes. Okay. So a little routing of the harness. There's the brains of the operation right there. There's our valve body. This is what it looks like out of the car. And when you're doing the valve body replacement on these top engines, you got these two O-rings right here. You got to replace those. And sometimes when you're putting the valve body into this crevice, those can get shifted around a little bit. So you want to make sure that you're putting that thing in straight down. Because if one of those O-rings gets split or it doesn't seal correctly, you are going to lose your line pressure and you're going to lose your forward reverse clutch. So if you do a valve body and you just have slamming gears and that car won't move, more than likely because those O-rings got pressure in them. Oh, also, yeah. If you buy a Subaru OEM valve body to replace in your transmission, it's going to come with this big tarp. And that tarp has a hole cut out in it that you can lay around the opening of here. And it covers up your entire engine bay and it covers up your hood. And it's designed like that so that way if you had a hood that was full of dirt, dirt's not going to fall into your engine and air's not going to blow dirt over into your engine. It looks like a big surgical tarp. If that thing is just too cumbersome for you to work around, I honestly just pressure wash the engine bays and the hoods of all debris, and then I shop air that whole area clean. Because trying to work around that tarp and let alone setting up that tarp is ridiculous. But it is necessary on some crummy cars. There are some cars that just cannot be detailed clean. Big changes to our oil pump is now your oil pump is accessible behind the torque converter. Before your Generation 1 wasn't like that. You had to tear down the entire assembly. That's nice. If you do pull this chain pump cover off, you want to make sure you're using a tool called an indexing pry bar or AKA lady slipper. And you have indicator marks by these blue arrows where you want to pop that thing off. Please, please, please take this thing off as evenly as possible. Just go in a circle, a little bit, a little bit, a little bit, a little bit, and so on and so forth, and make as many passes as you can to pull that thing out evenly. Because if you just try and peel it off like a band-aid, it's gonna snap in half. So your stator support on the shaft, we changed it up a little bit. If you remove the pan, then that's where you're going to find your sump filter. There is a second filter for the line pressure that's built into the main case, and it is non-serviceable. So as long as your sump filter is doing its job, you don't have to worry about the main filter. I like to change these things out about every 60,000 miles. And do not recycle your CVT fluid. Once it is drained, it's done. Uh, Cleaning up around this case area, about the most aggressive thing that I'll use is Scotch Brite, but I mainly use plastic scrapers. And avoid using red rags to clean up all the oil here before you go to seal this back up. Red rags are full of lint, debris, and they just peel apart left and right. You don't want any of that in your case. My go-to oil cleanup, chamois. Okay. Get on eBay, get on Amazon, and you can buy a plethora of them. Like they just sell them by the pound. Some of your strainers are going to have this little bit of a straw coming out. Be aware of what you take out of your transmission as it needs to be the same one. If you're buying aftermarket sump filters, be aware that some of them don't come with O-rings on it. OEM sump filters will come with an O-ring. No O-ring, no seal, bad problems. What this straw does is this straw will help out with preventing champagne bubbles or aerating your fluid. If your filter doesn't have it, don't worry about it. It just means that the aeration is being taken care of somewhere else in the transmission. So I would only use OE sump filters. There is a magnet in the tray. That magnet, this is normal amount of wear from the transmission. You're always going to get a little bit of smooth, as I call it. Okay. You just wipe it with your finger and it's almost like anti-seize. That's normal. But if you got grit, you got chunks, that's bad. Something's really breaking down. And if you just got pieces, well, then something's broken. You'll notice right here that there's this plastic shield that is a baffle plate that is to help protect the chain, keep it lubricated with splash oil. This is a generation 1 here on the right. It doesn't have that. So Gen 2 on the left, Gen 1 on the right. You're doing a zoom in here on this sump filter. You'll notice that there's all these black specks right there. That's gasket maker. So this pan was being dropped again because somebody did a bad cleanup. They whizzy wheeled it, and gasket maker got trapped up in that sump filter. So I had to replace the sump filter again. All right, and where are we at right now? 10 o'clock, guys. I think we're just going to go right in the Q&A. What we got? Everyone's kind of getting tired. We're running late. Sorry, didn't move fast enough. But next Saturday, we are going to get into our cooling, how the transmission stays cool, how the engine helps out with warming up the CVT fluid by using this pancake cooler and heater here. So it heats and cools the fluid at the same time. An introduction of a new thermostat to this cooling circuit right here. We'll talk about the thermal control valve body circuit and its benefits and what we're doing to compete with it because it's honestly just got a high failure rate right now. How to burp the system, special tools, and the CAN bus system. I think we'll get through the next one super fast because it's all gee whiz. We really got hung up on power flow and the valve body, but I think one more rehearsal of that, I'll be able to get this down to 2 days. I really want to help. I really want to thank everyone for sticking it out with me and helping me refine this presentation. I'll make some notes of what I got hung up on today and simplify everything and get my tangents down a little bit because I ultimately want to get this into a 4-hour 2-day class. So if we have nothing in the chat, then I will salute and thank you for being with me today. You guys were fantastic. And Fluffy, I want to thank you for that $5 so much, man. It helps out a lot with getting these classes pumped out. Again, this stream is going to be available until I upload a better one. So you guys can reference it as much as you want. Take care.